Hello everyone, welcome to Successful Kubernetes Development Workflows. I'm Al, I'll stay here in the corner. Before we start talking about Kubernetes development workflows, I'd like us to take a quick detour and talk about IDEs just for a second. So I assume most of you are familiar with IDEs. You learned to code using one, or you didn't, but you learned about them afterwards. Either way, you know kind of what IDEs are. Now, what IDEs do is that they address a bunch of problems that developers wanted solutions for. So they provide you with syntax highlighting, code completion, a bunch of stuff like that. And these things are basically, so the I in IDE stands for integrated, and an IDE is basically a collection of solutions for a problem set that is common among developers when they're trying to code. Now, me particularly, I have an interesting relationship with IDEs, and that's because I didn't know they existed for the longest time. So for many, many years, my IDE was this. And I wrote rootkits in C using Notepad. I wrote my own WordPress before WordPress came along in PHP, also using Notepad. And I didn't know, because I learned to code basically from books, and I lived in a small city. I didn't have any friends. So it took many, many years for me to actually learn that IDEs existed. But I mean, it was fine. I could get the job done. It was just a lot less convenient than it could have been otherwise. So let's tie this back into Kubernetes. So lots of us here watching this talk at KubeCon, I would bet that a good bunch of you watching here, I would bet that a good amount of you can write Kubernetes YAML by hand from memory and it would run. I bet a good chunk of you know everything there is to know that is relevant about containers and Kubernetes and so many other technologies like that. Basically, we're the people coming to KubeCon. We know all this stuff. Some of you even know what this is. And if you don't Google it because you're going to have nightmares. But if you do know this stuff, you know what I'm talking about. And the thing is, we learned to code using the equivalent of Notepad. We learned to do things by hand because when we started, we had no choice. But that's not the case anymore. Nowadays, there are many solutions not packaged up in an IDE form, but there are many solutions that fixed lots of the inconveniences of developing for Kubernetes. And what I'm trying to say here is that we should give people good tools because even though doing things on Notepad worked for us, like it worked for me, we shouldn't expect that everyone else is going to learn in the same way if it's not the most convenient. So containers in Kubernetes are incredible, but except for the development workflow, which has problems. And everyone complains about these. If you're on Twitter, you're going to recognize everything I'm going to talk about. So what I'm going to do here is I'm going to tell you the most common problems. So I'm going to give you the problem set, and I'm going to tell you how many different companies, teams, and projects solved those problems. But the thing is, we don't have the I in IDE yet. It's not all integrated. So I'm going to give you a bunch of solutions, and you're going to pick them yourself. So let's get to it. I'm Al. If you want to see that picture, there you go. I work at Tilt. Previously, I worked at Garden. They're both companies focused on the development experience side of Kubernetes. And that means that half my job is listening to developers complaining about their development workflows, working to solve them. And the other half of my job is basically coming here and sharing those findings with you. I'm going to repeat this slide again at the end if you want to get all the contact information. Now, what are the problems? The problems are 1, development clusters. 2, managing a boatload of config files. 3, getting feedback after you write your code. 4, sharing cluster context, and I'm going to explain what this is when you get there. And extras, you know this word, it means extras. Okay, protagonists. I'm going to tell you about how these groups fixed those problems. They are, 1 is Datadog, a cloud monitoring SaaS provider. I'm sure most of you know Datadog. Their engineering team has about 800 developers. I'm going to talk about Uno, which is a smaller but not tiny company. So they're a manufacturer of electric scooters in Berlin. Their scooters have internet I don't know how that works, but yeah. Their team is about 25. I'm going to talk about Mindspace, their creative learning and gamification agency. Very tiny. Their development team is 4 people. So here we have examples of 3 different magnitudes of problems and solutions. And we also have Cluster API, and we have probably a bunch of friends from Cluster API presenting at KubeCon right now. And with Cluster API, basically you can have a management cluster that you use to create and manage other clusters. So you have your management clusters that you use to create a cluster on Google and Amazon and Microsoft. And it's like you manage clusters the way you manage Kubernetes resources. That's basically the idea. Their workflow is very weird compared to the typical app dev workflow, and that's very interesting. They have about 230 contributors. It's an open source project, so people come and go, but I think that's the number I got from the repo. This is a funny joke my friend made when working on Cluster API, and the point is that you can run your app in a container, you can run your app in a container in a VM, and then you can run your app in a container in a VM, and that app is going to create other containers and VMs that runs apps. And yeah, Cluster API sometimes takes some efforts to understand, but anyway, let's move on. Development clusters. So if you're not using a development cluster, you're basically developing a notepad, because you're writing code that's supposed to run in a cluster. If you're developing it outside the cluster, you're going to end up with discrepancies. And that's annoying, and that's hard to track down, and you don't want your developers to have to deal with it. So you should just use a development cluster. Now, there are 2 types you can use. You can use a local cluster, you can use a remote cluster. The local one runs on your laptop. The remote one runs at Google, Amazon, Microsoft, etc. If you want to use a local cluster, the first question you have to ask yourself is, does my system fit my laptop's RAM? If it doesn't, that's going to be hard to use a local cluster, but not impossible. But that is the main question. If your app is too big, you can't use a local cluster. Now, there are many types of local clusters. So here's just some examples: Minikube, Kind, MicroK8s. They all have their pros and cons, so you need to know what you're doing and what they are good at. So when I talk about Cluster API, I'm going to tell you why they're using the specific type of local cluster that they're using. The good thing about local clusters is you just double click to install. You don't have to pay a monthly fee as long as you can, pay electricity to run your laptop. And the main thing to be concerned about is compute. So your laptop is going to run out of memory, or it's not going to have enough processing power. That's the thing that might be annoying. Network is not so much of a concern, because you don't need to be pushing and pulling things through the internet. So that's not so much of a problem. It is a problem, though, if you're using a remote cluster, because if pulling images and pushing images takes a lot of bandwidth, and that means a lot of time, depending on how good your connection is. So you can, with a remote cluster, you can have like infinite memory and CPU, but network is going to be an annoying issue on your development workflow. So that's something to pay attention to. Now, a remote cluster, like I said, the main advantage is infinite RAM, infinite CPU, but of course it costs cash money dollars, which is annoying, and you need to pay attention to if you don't want a big surprise. It requires more infra to set up and maintain, so you can't just double click to install. You have to have someone with experience in these things to provision all the infrastructure that you need to maintain it. And basically to do better than just fiddling around, because if you don't know what you're doing, you're going to end up wasting a lot of money. So you don't want to do that. Right, so Datadog, how do they deal with this issue? They have 300 plus services, so it won't fit a laptop. They use one huge development cluster in the public cloud that is self-managed. So people always ask, should every developer have a cluster? Should everyone work on one big cluster? What I always see is everyone develops on one big cluster. You split either by teams or by developers where everyone has their own namespace, and usually that's how it's done. Datadog has wrapper tools for provisioning, so developers don't have to do any of it by hand. And something interesting is that they have like a staging where every service is running in like basically the stable form of it, the current form of it. When you're working on one of them, you basically clone it into your namespace. You modify the version that is in your namespace. but you don't need to run every service again in your namespace, only the one you're working on. The other ones that you're not working on, you can just use the ones that are in staging. So that's really cool. It's something I hadn't seen before talking to Datadog, and it's an interesting pattern. They also have options where you can inject debugging tools into the things that you're working on and so on. And this is a more common thing in big companies where you basically have a push button and suddenly that container has a ton of debugging tooling and that kind of thing. Mindspace, they do micro-K8s on Linux, but mostly they use Docker for Mac. They use Docker Compose for tests because running Kubernetes in CI can be a bit fiddly, so they use Compose for that. And their local clusters are basically exactly the same as in production, as what they run in production, except for number of replicas and that kind of a thing. And this brings me to an important topic, and that is Kubernetes on the laptop is fine when you do it right. So everyone's always joking around, oh, Kubernetes on the laptop, it's going to set your laptop on fire. That's silly, la 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 la. No, if you know what you're doing and you're doing things at the right scale, Kubernetes on the laptop works just fine. So let's stop with the silly thing of bashing Kubernetes on the laptop, because that's pointless. I would never tell Mindspace, this company, to use a remote cluster when they are 100% happy with a local cluster and they don't want or have to deal with the extra complexity of managing a remote cluster. Moving on, Uno also works, also uses Docker for Mac mostly, and here we have an interesting case. And I just told you that if you're doing things at the right scale, a local cluster is fine. When you're past a certain scale, you need to move on to a remote cluster. Sometimes you're past that scale and you can still handle things locally because it's convenient. So how do you do that? What Uno did is that they split their app into core services and optional services. The core services are always running. The optional services don't depend on each other. They depend only on the core services, and they are basically flip switches that you can turn on and off. So you run all the core services plus that one that you're working on. Then you turn that one off and you turn the other one on to work on that one. And basically, as long as you're not running everything at the same time, it works fine on your laptop. I assume at some point they're going to grow past it and they're going to have to start using remote development clusters. But right now, this has been working for them, even though it's been a long time that they can't run everything on the laptop at once. They still have a workflow where that can work. So that's interesting. And they are very amazing at automation and that kind of stuff. We're going to get to that in a second. Cluster API. They use Kind as the local development cluster. The reason for that is because when your business is creating and deleting clusters, you want a solution that can create and delete clusters fast. And Kind is very good at that. So with Minikube, they would have trouble. With micro-K8s, they would have trouble. They use Kind because it's the perfect solution to that issue. Which once again brings us to the point that you should know the tools that you're going to use, and you should use the right tool for the right job. And usually when people are screaming on Twitter, it's because they're using the wrong tool for the job. Now, Cluster API, of course, you can use it to create clusters on basically every cloud. And so it does use every cloud, but for the initial management clusters, they usually recommend Kind. Takeaway, if you're a small company, use a local cluster. Once you can't fit your app on your laptop anymore, then you move on to a remote cluster. But you need to know that that move is going to be costly because suddenly now you're paying a monthly fee and you're going to need a professional, you're going to need the expertise to create, to maintain, to modify that remote cluster. And of course, that's also a consideration. Now, config files. Config files are a problem, and I'm just going to start out by saying that if you're writing YAML by hand, you're developing a notepad. We don't want to do that. Developers don't like to do that. It's a great way to make mistakes, which we can simply avoid. The reason is that even for the simplest Kubernetes app, you're going to end up with a ton of YAML. And basically, if you change the name of one thing in one of them, you're going to have to update it on all of them. And that's hard because we're humans. We make mistakes. So what should we do instead? Datadog uses Helm. So they use Helm templates, different values for different environments, of course. You don't need 100 replicas in development. You just need one. And basically, you write YAML the first time when you create a service. You do the templates and all of that on Helm. and everyone else basically it integrates with Tilt. No one else has to think about it except the person that writes it the first time. I'm going to talk about Tilt in a minute. Mindspace, same thing, Helm templates integrated with Tilt. What they do that's different at Mindspace is that Datadog is huge, so there's a very broad range of services running. If you're doing something smaller, you can make services very uniform. So a silly example of that would be take the same YAML, same Docker file, same everything, just change the name and the binary that it's going to run. Basically, of course, it's not that simple, but you get my point. Uno does a very similar thing as Mindspace does, but they have some options where you can override things depending on what you're doing. So, the templating is a bit more complex, but again, same idea. Cluster API, once again, everything is extremely uniform, just like Mindspace and Uno. So it's very easy to, you create a new service, you basically Control-C, Control-V and change some properties. Cluster API uses lots of overlays because they use Customize and not Helm. So Customize has this concept of overlays, which is different. Once again, everything's extremely uniform. So I think the big takeaway here is if you can make things very uniform, do it, because it's going to save you trouble. If you don't know how the templating stuff works, basically here you have the template on one side, the generated YAML on the other side. You change the template and it propagates into all the different config files. So you don't have the risk of updating one config file, forgetting to update the other, and then they don't mesh well together anymore. Takeaway, everyone uses a templating solution. Big companies, sometimes they create their own templating solutions. I would tell you to not do that unless you absolutely know you have to. Most people use Helm, I think, from my experience or from the companies I've been in touch with. And there's a lot of integration with tools like Tilt, which is the next category we're going to discuss. Feedback loop automation. So, well, let me tell you a story. So if every time I make a change to my code, I need to Docker build, Docker push, and kubectl apply to see my change running live, if I need to do all of this, I am coding with Notepad. That's silly. We don't want to do that. And sometimes people say, okay, yeah, but I'm saving 30 seconds at a time. At the end of the day, that's maybe 10 minutes. Is 10 minutes of developer time that important? And the question is, you're asking the wrong question. I don't care about the fact that it takes 10 minutes. I care about the fact that every time a developer has to do that, they're moving their focus away from what they actually want to be doing. So you have a very high cognitive cost to being interrupted all the time. If a developer can simply save a file, blink their eyes, and their new code is up and running instantly, that is ideal in terms of both being productive and two, being happy as a developer. Because when you have a ton of boilerplate in between you and getting your job done, you feel miserable, and we don't want that. So what can we do? There are plenty of tools. I'm going to talk about Tilt, but there are others like Garden, Scaffold, Draft. Basically, these tools, they watch your source code. Every time you make a change to your source code, the conventional workflow is you rebuild that Docker image, you ship it to registry, you update your development cluster with that. And this is all behind the scenes. The developer basically just changes a file and waits a couple seconds. They don't have to do anything by hand. The workflow that most people are using now is live update, where you make a change to your code and there's a container that is permanently running, and you simply update a binary or source code into a running container. You don't restart anything, and it's very, very fast and snappy. Now, I posted this on Twitter. Basically, how long does it take between changing a line of code and that code being live and running in your development cluster? A lot of people said 30 minutes, which I find really sad. I always aim for 2 seconds. You can get to 2 seconds. I have a whole talk about tips and tricks and hacks to achieve this. The smallest the time, the better. You should aim for feedback loop time being so fast that you don't have time to pick up your phone and look at pictures of cats. Now, Datadog, they use Tilt. Currently, 40% of developers use Tilt. They're rolling it out. They have, so Tilt is one of those tools that allows for tons of customizations. And Datadog, they basically pull their CI image locally, and then their CI images builds things locally, which are then synced into the build cluster, into the dev cluster. So that's cool. Of course, they use Helm from Tilt. So basically, when you change a Helm template, you don't have to run Helm. Tilt's going to do that for you. So for a developer, it's basically I change something, I save a file, magic, it's up and running. And they create lots of buttons in Tilt to help with discovery. So that's really cool. What this means is, if we look at the green things here, those are all my services, except for the last one. That one's a custom button. Of course, you have services on one side and logs in the other in this dashboard. This is what Tilt looks like. And when you click that button that says Flush Database, it's going to, of course, flush your database. Sometimes you have a lot of automations in your make file and people don't know about them, and thus they don't use them. And Datadog uses all of these buttons to facilitate developers knowing things that they can do. So, for example, there's a button to get dependencies, there's a button to do database migration. So Uno is also very interesting in this regard. It's one of my favorite companies. They automate basically everything that is humanly possible. The Tilt extensions feature was somewhat inspired by what they were doing. And it's really cool. So they automate setting up internal proxies, TLS management, Vault integration, using tracing as a developer tool, a bunch of crazy stuff with Mongo that I don't know enough to explain to you. Basically every possible thing that can be automated, they do. They automate things with Tilt. So it's a very smooth workflow where basically a developer doesn't need to worry about anything. They just get things up and running with one command. They write their code, they change their code, and everything else in the whole world is automatic. And they don't have to think about it. So a big shout out to David Rubin for all his amazing work there and for writing the first third-party Tilt extension. Now, Mindspace. Mindspace was one of the first users of Tilt. Their usage of it was similar to Uno, but basically so many of the customizations that they wrote for Tilt were then turned into native features that now they basically use vanilla Tilt. But their setup is somewhat similar to Uno. Now, Cluster API, they have lots of interesting things. So they automate a bunch of stuff like certificate management, like what I talk about Uno. They have a bunch of overlays so that there's like this custom automations, and then you can overlay certain things on top of the custom automations. So developers don't have to all have to do the same thing. They can customize some things. They used to build binaries inside containers. Now they build things locally and they live reload binaries into basically a Scratch container. It's not Scratch, but it's kind of like Scratch, so that they don't need all the Go toolchain inside containers. So that is cool as well. Takeaways: when you have a very uniform structure of services, which we talked about in the previous section, you can do lots of cool things with automation, and that is really cool. So that's the stuff that Uno does, the stuff that Mindspace used to do, the stuff that Cluster API does. With Datadog, it's a bit more complicated because they're very big and they have things that are very different, but they also do tons of automation as well. So takeaway is, use a tool like Tilt or Garden or Scaffold or Draft. Automate the bejesus out of your system so that developers can really focus on developing and not on boilerplate. Cluster context sharing. This is basically something happened, you need your friend to look at it. How do you do that when your environment is not your computer, your environment is a cluster, and your binary is not a binary, it's 35 binaries in a cluster. So if you're copy and pasting logs, here there's some give and take. I'm not going to say that copy and pasting logs is always bad, but it's kind of getting into Notepad territory. So for Datadog, because they have the big, huge development cluster, when someone needs to look into what their colleague is doing, they just switch to their namespace. So it's pretty easy. I've seen also this pattern in other companies of the scale of Datadog. So this is a very common thing to do. So use a wrapper tool, don't use kubectl, make it easy for your developers, and they can just switch around namespaces and see what their colleagues are doing. Pretty easy, problem solved. For Mindspace, and I did this research before Corona, so I don't know what people are doing now, but they were doing things the analog way. So here's my laptop, take a look at it. And you know what? At a certain scale, that is better than high-tech solutions. Uno was in the same space, except that Uno uses so much automation, so if anyone has ever had the same problem twice, they just automate it out of existence. So congrats to them, and it makes it so that things are easy to use in this regard. Cluster API uses snapshots. That's a feature of Tilt, which is basically you have the Tilt dashboard that shows all of your logs, all of your alerts, everything. When you take a snapshot, Tilt basically packages up all the current state of your application. You can send that to your friend. They just click a link, they open it in the browser. They suddenly can see all the logs, all the alerts, everything that your application is currently doing, the current state of it. And then that makes it easy for your colleagues to help debug what's going on in your cluster. Takeaways: if you're a big company, you have a big cluster for everyone, a different namespace for everyone. Just look into your colleague's namespace and then you can see what's going on. A middle ground is you can use a feature like snapshots. And if you're a very small company, just use the analog solutions. Don't bother with extra complexity. Though I think if you're already using Tilt, you should just use Tilt snapshots, but that's a separate discussion. Now, a couple of extras. We are getting close to the end here. So Datadog and Uno, they don't use debuggers, a debugger like GDB. They don't use those. They always output things to logs, and then they use tracing as a debugging tool. So Uno uses Jaeger. Datadog, of course, uses Datadog. So Datadog, dog feeds Datadog. That was hard to pronounce. And a common complaint about tracing is that you have to adjust your code to include tracing. It doesn't just work on top of what's already there. You have to put the code there. I asked Datadog about this and they said, oh, you know what? We have this auto instrumentation thing here that for a good chunk of people, it solves the problem. So kudos to them, and that's great. And I look forward to being able to play around with that myself. This is what tracing looks like. So here you have basically one request getting traced through a bunch of services. You can see the blue thing there is basically things moving inside one service. Once it changes to orange, that means that request is now on another service. And then you can just track as one request goes through many different parts of your application, you can see where it goes and what happened along the way. And that is a cool thing too. Mindspace, they use regular normal debuggers. So they use Tilt to do the exposing the parts thing, and then basically their IDE connects to the node remote debugging thing, and that does the job. And Cluster API is probably the most analog thing here, where basically they don't have a use case where they really want to use an actual debugger. So their debugging method is a ton of print lines that then get output to the console. They have a very fast feedback loop, so that works for them. And if you're going to use this, if you're going to do a print line debugging style, I would suggest using a tool like Stern to aggregate all logs. Of course, if you're using something like Tilt, Tilt does that for you. But if you're not, Stern is a great way to do this as well. Takeaway: integration with tracing and debugging tools is kind of rare, but growing, especially tracing. I see a lot of people using it more and more. It's easier, I think, than debugging. Debugging, it's like once you're in that mind state, it's great, but until you get there, it can look a bit daunting. So, takeaway: notepad.exe is not a development environment, so let's not do that. Let's give our developers proper tools to make their lives easier so that they're happier, and you know what? So that we make more money. Yeah. So thanks for coming to this talk. And one more thing. We're creating my team at Tilt, we're creating this website called dax.dev. We're going to have videos, articles, and live stream about developer experience. We're basically going to talk about all the things that I talked here, like should I use Helm or Customize, should I use Kind, Minikube, or Microcates. So we're going to have a ton of content about all of this stuff. By the time you're watching this talk, we're probably going to already have something up there. Right now it's just a sign up page. So do sign up if this floats your boat, so that you can learn more as we learn more about the subject. So here's how you can get in touch. Here's links for all of those companies. Please do reach out, tweet, message, email, and talk to you soon. So thanks for watching this talk, and bye-bye. Have a great rest of the conference.